Hello students, in this video we'll prove that power functions are differentiable at any point. Let's prove that f of x, which is x to the power n, is differentiable at x equals c. To do this, we need to show that the limit of the difference quotient exists. So we're going to consider the limit as x approaches c of my function f of x minus f of c over x minus c. That's my difference quotient. This is exactly equal to what? Plugging in x to the n and c to the n, we have the limit as x approaches c of what? Of x to the n minus c to the n over x minus c. Now, x minus c is a factor of x to the n minus c to the n. X minus c is a factor of x to the n minus c to the n. And how can we see that? We can use synthetic division to tell us what the coefficients are. So here's, I put the c in the box, and I have a what? I have a 1, which is the coefficient of x to the power n, right? Then I have a whole bunch of zeros. Then I have a c to the power n with a negative sign over here. So to do synthetic division, you bring the 1 down. Then I'm going to have a c, then I multiply, I get a c squared. Bring the c squared down, etc. All the way down to what? All the way down to the last one, which is cn minus 1. And then I'm going to have a c to the power n with a positive sign, so I get a 0 over here, so that proves it's exactly a factor. And so what our synthetic division tells us is it tells us that x to the n minus c to the n is x minus c times this x to the n plus 1 plus c x to the n minus, that's an xn minus 1 obviously, so let's clear that away. Made a little error there. It's going to be what? X to the n minus 1 plus c x to the n minus 2, all the way down to what? All the way down to c to the n minus 1. c to the n minus 1, okay? And so therefore, what can we say? We can simplify our limit. Our limit is going to turn into what? Just the limit as x approaches c. Now I can cancel out that if I do the division, I'll just have that leftover polynomial. So it's exactly equal to this polynomial over here, x to the n minus 1 plus c, x to the n minus 2 plus c squared, x to the n minus 3, all the way down to what? All the way down to c to the n minus 1. And now by algebraic properties of limits, I know that as x goes to c, x to any power is going to go to c to that power, right? So by algebraic properties of limits, we know that this is going to go to a c to the n minus 1, a c times c to the n minus 2, a c squared times c to the n minus 3, all the way down to the constant term c to the n minus 1. And all those terms are c to the n minus 1. How many c to the n minus 1s do we have here? We have n copies. So there's n terms over here, n terms. And so we have over here is we have n times c to the n minus 1. And that gives us our familiar product rule. So that tells us, that's our familiar product rule. So the limit exists, great. And that tells us that if f of x is x to the power n, we've just proven that its derivative for any point x is n x to the n minus 1, provided that n is a positive integer. Thank you very much.